ladies and gentlemen, so here's our review sheet for our stats test. And remember, the test is probably going to be a little bit easier than this. But some things to remember is that if you enter your data into lists, so if I have just one variable data, so one variable stats lets you do a bunch of things. It gives you the mean, it gives you the median, it gives you Q1, Q3, minimum and maximum. It will also give you your standard deviation, theta. All right? If I do two variable statistics and I do a linear regression, that's where you're going to get your equations and you're going to get your R values. All right, so you need to know which ones you're dealing with here. So here we're talking just about one set of data. So which measure best describes the data? Well, it's certainly not the maximum. There is no mode. If you put this into your calculator and get a mean or a median, but the idea here is that this number is so low from the others that the mean is going to be pulled down lower. So your best choice would be the median. Number 2, Abe found the mean and the median of this list of numbers. If the number 6 were added to the list, what would happen? It would make the mean increase. Right now the mean is, 7 divided by 3, so 2 point something. But then if you add in the number 6, now it's going to make it a lot higher. But the mean certainly isn't going to decrease. The median is going to stay the same. It's still 3, which means those two don't make sense. And that was a pretty quick calculation you could have done. A small business owner wants to hire seasonal workers as the need arises. The following shows us if the mean of the data is approximately 7, what is the population standard deviation? The fact that they told you the mean has nothing to do with the problem. You simply enter this in, do your one variable stats, and do your, this was a one variable stat problem. And you found your theta, which was 3.3. Going back over here to number 4, and we want to know what happens if I add 5 to each of the numbers. Well, I actually did that and then just went through and found what would happen. The mean will not be multiplied by 5. The mean will actually be increased by 5. So the mean will not, this one didn't work. The standard deviation didn't change. And again, I just went through and looked at those. For the median, you could enter those into your calculator, but if there's 25 students, the number that's in the middle is the 13th number. So I literally just started counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th. That would have worked the same way from the other one, so the median was 10. Doreen is analyzing a box and whisker plot. And again, if you go through and, well, you need to know what a box and whisker plot tells you. So it does tell you the highest because we want to know which one is unable. It does tell you the highest. It does the median. It does not show you the mean. And it does show you the lowest. So that's just knowing what it does. Now actually looking at some, I put this into my calculator and I did my one variable stats. And then I went and just found which one matched. Because if you do this, your Q1 was 72, your median was 86, and your Q3 was 101. So then when I went through, actually I thought your Q3 was 103. Hold on. So that means that it can't be A because you don't have your Q3, which is the end. Can't be there, can't be there. So then when I looked for between C and D, choice C has your Q1 at 70. This one has it at 72, so it was choice D. Reading the box and whisker plot here, so it shows 50 statements. Again, just being able to read it. Which statement is true? And the lowest high temperature is 70. Well, the lowest high temperature was 40, so that wasn't it. Half the cities had a high temperature of 75 or greater. Well, here's 75. And greater, it has 2 sections, so that is true, 50%, because that was your median. Looking at number 9. What percent of the students of the heights of the students is between 60 and 65? Well, 60 is here, 65 is there, so it's that middle section, which is 50%. Because each section represents 25% of the data. How many students score between 42 and 56? So 42 and 56 is just this area. So that's 25%. I need 25% of 600, which I believe was 150. So that was doing a little bit of calculation. For this one, create a box and whisker plot. And again, I literally entered all that information and I did my one variable stats. And it turns out that your lowest is 1.5. Your Q1 was 0.2125. Median, 0.25. Q3 was 285 and your highest was 0.3. So this was your box and those were your whiskers. And again, I certainly just all I did was put it in my calculator and then draw the box based on the numbers it gave me. Number 12, use a line of best fit. So I actually went through and kind of extended my line. I used a straight edge to do that. We want to know for 9, how many minutes would it be? So closest to 5 minutes. Oh, that was it for that one. 13, we have here what's happening. So we're going down, even if you didn't put a line in. So which one makes sense? Well, as traffic volume increases, vehicle speed increases. Well, that certainly isn't true, because then it would be going up. It was choice B, as traffic volume increases, speed decreases. Next one, number 14. So here you had to do a little bit of reading. So it says to represent the data as a scatter plot using the number of years since 1980. So this would be 0, which means your X minimum cannot be 1980 or 1975. So we're down between B and C. And you're not going to enter these as the actual thousands. You're going to put them in as 150, 140. So it was choice C. Number 15, which scatter plot below, you answer the following, which shows a strong negative. That means we need it going down and coming as close to a line as we could. So it was choice D. For number 16, I actually put this one into my calculator, but if you draw a line, even if you just kind of draw a line here to try to connect these or put in a line of best fit, it's going to go through the origin, which means C and D are gone. And then it's going, if you try to pick 2 points, it's actually A. You're going up 5/3 to get to your next point. You could put it in your try to approximate the dots and put them in your calculator and pull up a linear regression line and see which one comes close. So you could do that as well. For this one, you had to actually make, well, you didn't have to, but I did that. So I just put my numbers on here. So 1, 3, we had a 2, 1, we had a 3, 4, a 4, 7, 5, 2, a 6, 6, and a 7, 3. So when you take a look at this, there is no relationship there, right? There's no relationship. The scatter plot does not seem to be going up or down. It's kind of all over the place. For number 18, I again put this into my calculator, but you should know that if you're taking a look at it, first of all, it's going down, which means you can get rid of C and D because those have positive slopes, and you're certainly not going down 40 degrees for every hour. So A doesn't make sense. B is your closest one. 19, taking a look at the 2 different scatter plots here. So we want to know the minimum passing score was a 70. And so you basically had to figure out which class had the greater, or the difference between the passing. So here, 70, only 25% of Class A. Class A had 28 students. So divide that by 4, so only 7 of them passed. In Class B, here's the 70, so you have 2 sections, you have 50%. So 50% of Class B is 16. They want to know how many more. 16 minus 7, 9 more students passed. Which of the following is a symbol used for the correlation coefficient? That's choice B, letter R. Let's see, the correlation coefficient for X and Y is known to be 0. What can be concluded? When it's 0, that means that there exists no linear relationship between X and Y. Actually, it could be either, you know what, I'm changing that one. I think it's B. There's no relationship at all between X and Y, let alone linear. 22, And we know that it is a correlation of 0.75 was found. Well, it can't be negative because it's a positive. And we don't talk about one of independence. So it would be a weak and positive because it's kind of far away. For number 23, first of all, I didn't even look at 4 because it wasn't a choice. But then what I did is I just went through and entered each of these, and I did my linear regression to get my R value. This one had an R value of negative 0.45. This was negative 0.01, negative 0.97, and negative 0.58. And again, I did that all on the calculator. So which one shows a strong negative correlation? Choice 3, letter C. It had the one closest to negative 1. And this test is a lot of calculator work. Linear correlation coefficient, again, I entered it into my calculator. Turns out to be A, 0.977. For number 25, I didn't actually make the graph. All I did was I did a linear regression. And I got my equation for that. So my equation was y equals 4.93x plus 1.75. The R value was 0.999. So that's actually a pretty good R value. It means it's almost a straight line. And then I did for point C, I put in the 12 years for X. So 4.93 times 12 plus 1.75. They wanted it rounded to the nearest tenth, 60.9 feet. For number 26, identify whether the following situation represents causation. Remember, causation is one is causing another thing to happen. So we're saying increased highway patrol presence increases the severity of accidents. Well, that was a lot like our fire question. So this is an example of a correlation. Right? We have that behind the scenes one that obviously the bigger the accident, the more police you are going to need there to help control the scene. For number 27, if you graph shoe size versus math proficiency, the positive slope indicates correlation only. Right? Just because you have a bigger shoe size does not mean that you are going to be better at math. Sorry for all those people who think that. And last but not least, question number 28. So I almost had you just cross this one off, but if you create a scatter plot for this, so again, all I did was enter the numbers, and I'm just going to kind of sketch it over here. If you create a scatter plot for this, you're going to see that it's going to be a nice exponential form, so that's all that I really did for this one. I entered all that information, I entered the numbers as they were, but it's going to be your best bet to an exponential. Perform an appropriate re-expression. That means that you would have to do an exponential regression, which you can do right on your calculator. It's just like linear, it's just a different button. And the equation that you get for that is 3.0 times 1.03 to the x. But don't worry about this one. And there isn't one that hard on the test. So for my students, morning help tomorrow. Be there if you want. But again, a lot of calculator work and knowing how to use it. Any questions? Let me know before the test. Have a good night.